Welcome back to the stream. I've got something kind of small and random here. Oh, Tuco, get away from that. Yeah. I was also just getting the stream started over on the cat camera. So we are now streaming on 3 places actually. So you can go to the main stream over at twitch.tv/scanlime, or if you search for scanlime on YouTube or go to youtube/melizabethscott, you can find the stream there. And you can also find the stream from just the robot itself, which is not interactive yet, but it's going to be in the pretty near future. Right now, I'm just looking for the cat. Oh, he's on the chair right behind me. It's the manual scanning for cat mode. There you are, little guy. So we have cat at twitch.tv/TucoFlyer. Also here. So yeah, the idea behind that is the Tuco Flyer stream is like more of like a behind the scenes, like robot's eye view of the thing. And in the near future, you will also be able to control the robot with chat commands. But right now, it's just a separate video stream. And yeah, and then there's the main stream on YouTube and Twitch. So today, actually, I've got to warn folks that there might be some flashing lights coming up. I'm going to try to limit how much of it there are, but if you're really sensitive to flashing lights, you might want to skip this stream. Because it turns out that I'm trying to debug a flashing light. We've had some streams in the past where we were trying to make lights flash for the flashing light prize, and in fact, if you're interested in entering the flashing light prize, I think there's still like a week. It's getting really close to the deadline, but yeah. Christian on YouTube chat says that they're never getting used to the time zones. It's pitch black in the middle of the night where they are. Yeah, it's bright and sunny here. It's like 3 in the afternoon. So yeah, there are a lot of things I could stream about. I'm trying to have a good balance between streaming and editing and writing code. And I really needed to get another video out about this project. So I'm trying to do more sifting through video footage. But let's at least do something streamy. Anyway, so this is going to be debugging a flashing light. So I was trying to get this stream started earlier today. I'm going to try to zoom out so that this is less bright on the... Oh, actually, the reason I had the camera there is I wanted to look at this on thermal, which will be less flickery. Yeah, so look at that. The thing that I'm immediately interested in is just how much heat there seems to be in the light produced by this bulb. So this is a 15 watt rated LED bulb. So I should try, I'm going to get a view of the label on the bulb in just a sec. But yeah, I think the brand name on this bulb is Hyperikon or Hyperikon, or I'm not sure how you say that, but maybe we'll find out. And this is their, I think, 38 millimeter, whatever that PAR38 is. That's their, this is a just an LED light bulb that was in my kitchen, and I took it down last night because it was flickering. And I figured this would be an opportunity to diagnose why it's flickering, see if we can repair it. If we can't repair it, maybe just reuse the parts that aren't busted on here. Because there seems to be a really great LED chip in this bulb that's still plenty good, and a power supply that's failing. It was installed in this orientation in a can. So I'm guessing what's going on is that the bulb puts out a bunch of heat. It doesn't have metal heatsink fins, unlike some of the lights I have in this form factor, and instead it looks like they probably have a metal heatsink under this plastic shroud. And then that's radiating some heat, but also just warming up the power supply up here, which is probably oscillating in and out of thermal limiting. I've also got a power meter looking at this to see whether when it goes dark, whether I'm getting an increase or a decrease in power, and it's definitely a decrease in power. So yeah, this was running kind of steady state for a while at 15 watts, like it's supposed to. And I had to delay the video for a while because it didn't look like I was going to be able to reproduce the problem. But it just took a while of running it normally for it to heat up enough to start doing this. So yeah, now it's taking less power than usual, and it looks like it's just oscillating some part of the power supply in and out of thermal cutoff. So, I think all that's left to do is to take this thing apart and see what's the design flaw and if we can reasonably fix it, or if it's just a matter of junking the power supply and repurposing the LED. In the meantime, my kitchen is a little bit less bright than it usually is. So I'm going to turn this off and spare us from the flickering and let it start to cool down a little bit so we can take it apart. I'm not going to like wait for it to cool down, I just figured we might as well do that slightly in advance. Tuco stole my seat here, which means I get to pull up another chair. Excuse me, boy. Oh, did I lose the camera? Sorry about that. The camera tends to follow shiny objects that swoop in front of the cat sometimes. Conceal my work in progress junk. There we go. There's Tuco. He only wears that collar when he explores outside, and he's done with that for the moment, so I can relieve him of the collar too. Oh, when I say outside, he's an indoor cat, but there's like an area outside of my particular shop here that he can interact with other cats. Oh yeah, he must have followed me over. Alright. Need to have some software changes to avoid that. Oh yeah, that's not a bad idea. I mean, James suggests just trying to add some heating or cooling to see if we can change the pattern. Yeah, I mean, I think we've all got a pretty good idea of what's going on at this point, but that might be fun, so let's do that before it cools down too much. I don't really want to like break it too much further, but I think a little bit of heat gun wouldn't be too bad for it. Emily's like, watch, but it solves it because of some other property, right? Watch as my desk bursts into flames. Oh, right. Alex says they want to display like a picture frame that just displays the Tuco flyer stream when it's on, a sort of a living cat picture. Yeah, actually, I was thinking about how to configure a tablet to do that, since it would actually be nice to have one of those like in the entryway here, so that it's like really easy to tell if you're like, as you're coming into the shop, like if the camera is like going to be pointed right at you. That might be fun. And yeah, I mean, my impulse for like doing it as correctly as possible would be to have like a network of SDI video drops around the shop where you can just pick off some video and connect it to a little LCD panel. But that's like more expensive than just having a bunch of like old tablets or Raspberry Pis running Twitch. But yeah, the low latency would be nice, but you pay for the low latency. And maybe there's some compromise where there's some tablet app that would give me lower latency video from the local source. Because I already do relay all the video from OBS through a local Nginx RTMP relay, And so that RTMP relay could be a point to grab video for local monitors also. Anyway, it's flickering again. Didn't take it very long to start up, but I got kind of distracted talking about CAD. And SDI video. SDI is nice. Oh, by the way, speaking of distracted about SDI, I was talking about this in chat a little earlier, and just talking about how I was talking about modding this, well, hardware to mod. There's a couple things to mod. There's this arcade cabinet, which I originally was going to use for this sort of music game project that kind of fizzled out. And I acquired it for pretty cheap, and it's got some like worthwhile parts in there, but it also kind of needs some work, and it's also kind of a funny game. The video doesn't work on there right now, or at least it didn't last time I tried. But specifically, this old Sunflower Mac would actually be much more useful to me as an SDI monitor, because it's a pretty decent LCD panel. I think it's a little higher than 1080p actually, so I might even need a scaler of some sort. So maybe even not an SDI monitor, maybe just like a plain old like DVI monitor. But it really just requires a physical modification because that panel is already electrically compatible to DVI. Yeah, and then that right monitor I'm also going to stick an SDI adapter on. But this thing I have over here is super useful. It's just on a little gooseneck clamp, so I can just take it around the shop. I've got this one cable, which is video and power. So one half of that is 12-volt power, and one half of it is HD video over SDI. And it's like 100 feet long and cost like $20. It's not expensive by cable standards, at least. And then, yeah, so on here, this is actually an LCD from Adafruit. I don't know if they still sell this one. I think they do. It's like, I think it's something that was probably manufactured for use in car dashboard kind of stuff. It came with some other kind of mount that I have it on this one instead. This one is just like a GoPro mount, I think, but it's all just 1/4-20 tripod compatible. And then you can see this mess, but so half of this is video and half of it's power. The video half goes into this blue cable where I've had to re-terminate the coax once already because it was flimsy. And so that goes into one of these cheap SDI to HDMI adapters, velcroed onto the back of the monitor, and then a tiny HDMI over into the back of the Adafruit thing. The Adafruit monitor actually has a good selection of inputs here, but I still needed an adapter for SDI. It also generates some warmth here. And the monitor happens to have a USB output, so I'm using that to power the HDMI to SDI, or the SDI to HDMI adapter. And that seems to work all right. I've used kind of the same strategy on other monitors, just it's a lot cheaper to find random HDMI monitors and stick an adapter on them than to buy like actual studio quality gear. And something like this, there probably isn't much room inside of it. If you wanted to make something like this more compact, you'd probably just need to 3D print a case and then eliminate some of this wiring by wiring the boards directly together. I've just loosened this somehow. This is not an optimal mount for it, but it's convenient just being able to like grab this and take it around the shop to see what the robot's doing. I mean, wireless would be more convenient, but then it would have latency. This is pretty much zero lag. It's the way this is implemented is there are some SDI splitters involved, but the original SDI signal is coming from an HDMI to SDI adapter, which is then plugged into just a spare output on the big GPU in the streaming machine. And so this is just a spare monitor on that machine, and so OBS has an option to mirror a video stream to a full screen monitor, and that's all this is. So the latency is pretty much as good as OBS's rendering loop. So I'm getting the video after it's being composited by OBS, asynchronously with the computer vision, so roughly the same time but a little bit laggy relative to computer vision. And then, so like it takes you like a frame or two to see the results of the computer vision on the stream, but like that's no different between the live stream that's going out and the monitor here. So it's pretty much as low latency as I can get with the computer vision overlays. And if I want the stream without the computer vision overlays, I can also tap into the SDI that goes from the monitor to the computer, and that's like no lag. There are no frame buffers involved in that situation, as far as I can tell. I mean, there might be a frame buffer in the camera, but everybody's got that at least. So, yeah, that's been all right. Oh yeah, the weather is nice right now. I know I've been complaining about the shop being cold a lot lately, but as you can see maybe by the like sunniness and what I'm wearing, it's not cold right now, which is actually really nice. Just when I get the right equipment to make a good thermostat. Well, maybe I'll have it control the blower fan instead. Actually, I've been thinking about doing some streams related to the fan here. I just didn't really have quite a good reason. The only reason so far would be to autopsy the so far 2 fan speed controllers that have blown out for the same reason. So I want to see what's going on there, but I got a nicer speed controller that I just need to hook up. But it's, you know, like you turn a knob. I haven't looked at it to see how hard it would be to hook up some kind of external input to it. It would probably require adding your own isolation. Now that we have it in focus, it's not flashing. I think that means we bring out the heat gun. Safety glasses? Oh, actually, I'm going to make sure I'm loaded up on tea here because I'm already feeling my voice failing due to dehydration. So I'll be right back, and you tell me if this starts flashing. Keep an eye on that cat, robot. It's your job. Be cold enough to drink someday. Let's put it not next to the power junction. Did I just drag the camera again? Camera, you're too distractible. Ah ha 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 ha. James is asking about getting video straight out of the IR camera. That's actually something I've been moderately serious about here. We don't need butt cam. Where's the cat? There we go. Yeah, and actually, so Kate Temkin, who also has some awesome streams that you should check out, she's actually done some firmware modding for this same IR camera. And so one way to do it would actually be to build on her work and actually just modify the firmware so that we can get video out over USB or even out over, like we could add a Wi-Fi chip in there. We could add, my preference would be to add Ethernet. As strange as that is, I would love an Ethernet port on my IR camera, which is obviously something that would require a hardware modification, unless you wanted to do that over USB. I don't know if that is on the go. You might need a separate device for that, but yeah. Oh, it starts. That's great. My tea will be ready someday. Alright, let's... Oh, I left the safety glasses elsewhere. Well, I don't think this is going to explode, and I've got regular glasses on. Let's just hit it with a little bit of heat. Let's have low heat, high airflow. and thermal camera. Seems like it's making the flashing faster. That might be my imagination. It's like over there especially. I really don't want to damage this further though. It would be really easy to damage this. I mean, the power supply is probably already toast, but yeah, it does seem annoyed, doesn't it? I don't really want to hit it with freeze spray because that would thermally shock it, probably. Maybe the air compressor, though? Maybe just some right side up freeze spray or air can. I've got an air can right here. I just don't want to thermally shock it too much. Let me just gently. I mean, we could try super cooling it if we wanted to. It's just, if we wanted to do that as an experiment and not as just like a stunt, then we would need to we'd need to try to not shock it. So like start out with it cooled and then see if we could reproduce the problem keeping it cooled, which doesn't make a very exciting test. Or just be patient, and once you've got it pretty cool, then put some freeze spray on it. I should be using my air compressor for this. This is just handy. This can is getting plenty cold. Thanks, thermodynamics. Yeah, I don't think this is cooling it enough, so I'm gonna turn on the air compressor. I'll be right back. did it stop flickering on its own? Of course it would. I mean, there's going to be a lot of lag between cooling the outside and cooling the inside of the unit. Are we going to have to use the heat gun to get it flickering again and then just have the air handy? This hose is so curly. Tuco is not going to have any of this air hose business. Which is good. I don't want him interested in this air hose. Yeah, I know my radio mic isn't on. I'm sorry. I'll go into more levels of meta next time. Mana is asking if this Raspberry Pi is doing anything. Not right now. I mean, I've been using it off and on for a bunch of things, but right now I'm not using it for anything particularly. Most recently I was using it for the Big Clown Labs gateway, where you can actually see their suitcase on the camera over there. Where's Took? I think he's somewhere over there. I don't want to desolder the components on the power supply while it's powered. That would be bad. I'm just trying to reproduce the problem slightly. I mean, it's okay. I mean, I'm generally like really into content feedback, so if you have info on the audio quality, then I'd love to hear it. It's just that I figured it would be pretty obvious why the audio quality was bad. It's like, yeah, I'm at the desk. I'm at the desk mic. I just got up to turn on the compressor. I figured you wouldn't want me to mic the compressor closet. Oh yeah, DK is asking if I've ever done anything with the Cisco telepresence camera. You know, I haven't done anything useful with it yet, but I think my best plan for it right now, actually, is to hook up at least one of them as a pan tilt zoom camera for these live shows and have it remote control over RS485 or 232, I forget which it is. But yeah, I mean, we've got a couple of them around, so we can do additional things. Let me know if you've got ideas too, but I think using them for this, or even for part of the Tuco Flyer stream, it would be on the table for sure. Sorry, desk. Sorry, Mike. Seems like right around here is relevant. Like this area. That's like around the colon on the caution, in the caution warning. Seems like around where the thermal stresses are most noticeable, at least right here to me. Joseph is asking about upside down duster. So yeah, I mean, obviously that's an option. I'm just worried that there'd be too much thermal shock and that it would just instantly damage it. We could do that as a stunt, but I think for an actual test, that would induce way too much thermal shock for it to be meaningful. I mean, this is already pretty effective. See this, and this is just air. I think this is maybe a better balance between effectiveness and shock. Sorry, it's loud. Oh, nice, cool. I guess DK is doing something similar with a camera on their desk, and it is RS-232. Oh, that's great. Well, yeah, I look forward to doing that mod. It seems really fun, and I would certainly be interested in, you know, like, knowing about what else people are doing with those and having some community around that. DK's asking if the case is plastic. Yeah, it's plastic. It looks like there might be a metal heat spreader underneath it, but the case is definitely plastic, and it's not very good at radiating the heat. So, yeah, I mean, I think I'm just like playing around. Like we knew a while ago that this problem was thermal, but this was in response to feedback to point a heat gun at it, and so I think we've explored that a bit. Oh, this tea is still way too hot to drink. All right, I'm gonna turn off the compressor and locate the cat. I'll be right back. Oh, he is way over here being sunny and awesome. Let's fly over and hang out. Let's see if I can make this work. He is enjoying a sunny area. This is going to be so much easier to fly when the computer is doing height control. There are just too many degrees of freedom right now. Oh geez, that's sunlight. That's sunlight. No, out of the sun. That's a little too close. I was getting my coordinate systems backwards in my panic to get it out of the sun. Jeez, I don't know how we're gonna detect sunbeams for real. I also don't know how worried I should be about the camera getting direct sunlight. I assume it's not good. I mean, I assume it's heating up the sensor pretty good when that happens. Whoa. Sometimes the navigation gets into spots that it has a little trouble with the tension management, I mean, more than usual, and it gets especially bouncy. I keep needing to reiterate that all the motion control software for keeping the multiple winches in sync right now really sucks, and that's a lot of why the wobbliness is happening. But my priority right now is getting another video out about it, I think, before fixing that problem. Because it would be satisfying to me to just like make it perfect before doing another video about it, but that's not really practical, and I think I need to fight that urge. And I think I do need to make a video that's more like, this is how it works with like all the really critical stuff taken care of, but like a really naive motion control algorithm still. Here's why even the naive one works, here's what it's bad at, here's how we can analyze how it's bad, and maybe that would be a good video, and that's something I actually already have material for. Oh yeah. Oh, well, thank you. Yeah, DK has some kind things to say about the project. Well, thanks. Yeah, and also a suggestion for it to go into sort of a seek mode when the cat isn't on the screen. Yeah, no, that's been a common suggestion for sure. And I think one question that's open for me is how much automation will be necessary versus how much just like letting people control the camera. I'm even just imagining how the sort of on-screen UI for the camera is going to be. I've started really liking the idea that the camera would have like a command queue visible over Twitch where you can give it things to do, and the commands I would imagine would be things like, look in a particular direction for a particular duration. So you could be like, and I don't know how you should specify the durations. Like when I've been doing this myself, just trying to so I've been doing experiments, just like watching only the Twitch feed and not watching the camera in real life, and just using the WebSocket-based controller and trying to control the robot and seeing what that feels like. And it does make a lot of sense to just think about, well, okay, I want to move the focus of the camera in this direction for this duration. And I can think about it in terms of, well, I want to hold down the manual controller at its maximum at this angle for this many seconds. And so it's like I can get used to that, but excuse me. But yeah, I don't know what would make the most sense for people online to see. I'm imagining maybe some kind of like on-screen power meter or something that you like kind of charge up and then release at a particular angle or something. But then yeah, I like the idea of having maybe some amount of automation to a search mode. So maybe even if you want to be able to manually aim it around, maybe you want to manually say, just like look all over the room, because I don't know where he is either. So maybe if you saw Tuco move in one particular direction, you could say, hey, go this way. But if you don't know where he is either, you could just say, hey, just like look around. And I mean, I could code that to work about as well as I could do it manually, probably. Oh, that's great. James suggests a UI where you could paint areas of interest. That would be fun. And DK suggests giving the users choices for objects to find, and then the camera can go off finding that object. Yeah, definitely. I think definitely having more computer vision interaction is on the table. I haven't really thought about just how to, like, when to do that work, like how much of it I should do before trying to retrain the neural network versus how much of it to do after we've got better object classifications. Okay, it wasn't going to keep up with him. I tried to lead it a little bit. It's still not good at the really fast jumps because it's actually looking for a block of pixels that's like an exact match. And so especially if he's getting ready for a jump, then he changes shape a lot. And if he's near the edge of the frame, then it doesn't have something exact to match him against. So for that reason, I think I need an additional computer vision algorithm that just does optical flow within that rectangle. So that's also on the table. Oh, a point of service. Yeah, kind of. That thing up there looks a lot like a cash register display, but it's actually a custom-built enclosure that I 3D printed around like a new old stock VFD. And so that's actually displaying. Why is it? Oh, yeah, the 0 is a glitch. It should be displaying something more like that. That's just telling me like how much data each machine is recording, and it's telling me that like the FFmpeg and the streaming processes are running. But yeah, no, totally. I could definitely, like once we get the neural network doing more custom things, because right now it's just running like an out-of-the-box neural network without any kind of customization, just to like have something to put in that slot in the design and that we know works and does the basic stuff at least. But once we have something that's trained specifically for this environment, then yeah, I mean, I would love to especially even find a way to, and maybe we could even use a really basic cat detector like what we've got now to train something more specific that uses, actual images of Tuco to just directly predict motion vectors based on that. That would be great. And that would definitely be within the capabilities of like modern neural networks. It would be like a bit cutting edge, and we'd probably have to figure out how to do it ourselves, but it would be really cool. All right. Well, I think I'm out of things to ramble about, so let's try opening this light bulb. Oh no, wait, I had one more thing to ramble about. I did have an update. The thing from last stream it exists now, and you can see it on Thingiverse. I had a stream last night where I just spent like 4 hours just trying to make something with FreeCAD and getting really frustrated, but eventually succeeding, and that was the result here. I don't know if I can recommend this program. There's a lot that it seems to be able to do, but there are also just a lot of dead ends in it, and the UI is really bad. But it was worth trying out for sure, and I might use it again. But yeah, the whole idea behind this was it was a thing that I could stick on the wall in the hallway, and it keeps the camera kind of from the side from seeing my keychain. And inside it's got a little magnetic attachment point. So last night, this was the project in FreeCAD, and it made it all the way to my wall and to Thingiverse, so it's got a happy ending. Yeah, so James says you could train it to detect like a tuco that's about to leap left, but I think there's this tendency, let me get a little bit meta for a sec. There's this tendency I think a lot of people reach for to try to segment problems into discrete states. So you want to define several separate behaviors, but I find myself really pushed away from solutions like that. I want something that acts as more of a smooth gradient between different states rather than having several discrete states. So instead of training like, here's a tuco going left, here's a tuco going right, here's a tuco going up, whatever, even if you make those vectors or whatever, I think you'd be doing better to have a closed loop system that analyzes tuco's actual motion in combination with the images, and you just get a train of images and actual motion vectors, and that's your data set. And then you can train something to say, given a picture of my cat, what do you think he's going to do in the next half a second? That kind of thing. I think that's the direction to go in. But yeah, I mean, cats are hard to predict. Like, I mean, one very simple variation of this that I think we can do pretty much as soon as we have kind of semi-autonomous winch motion is to have what I'm imagining is to have the winch get closer up to a certain point. You know, because it's after a certain point, either you have tracking problems because you're too big, or you're just not going to be able to focus. But so you have limits based on focus. You also have limits based on maximum size in the frame. But you do something where when Tuco's not moving around very much, so he's napping, you want to get a nice close view. But if he starts to stretch, if you see him get up, like usually what happens is he'll nap for a while, and then he'll stretch and get up. And then you can see him move around, but he's not going to get out of frame. So you can use that motion to cause the camera to back up, and now you have a lot more tracking freedom. And I think that also cinematically feels natural. Like, for me as a human photographer, I think that's likely what I would do. And that would also kind of open up the scene and tell you, you know, specifically that, well, now Tuco's world isn't just this little fuzzy, like, puff of sleep. It's now the whole room. And I think that works out nicely. Oh yeah, you want to see what the sign says. I have a better picture of this somewhere. Let me give you the cat full screen while I find the better pictures of this sign. Where did I put this? I don't think I have it on this computer. I might have made it slightly too hard to get to files from other computers from the demo computer. this where it is? Yes. I've got the source files. Let's see if I have anything that'll open them on this machine. I guess, thankfully, I think this was an Illustrator file, but, I mean, Illustrator files are also PDF compatible these days, and I did the actual vector cutting in Inkscape, so I have an SVG from Inkscape too. Alright, there's the sign. So, I just made that for the entry in the lab. I didn't make this icon. This is from the Noun project, and this is Creative Commons licensed, made by Phu Tran. I don't know how to pronounce Vietnamese names. I'm really sorry. But yeah, it's a great icon, and I just stuck some text next to it, and I chose some fonts and made sure it all lined up. Did all the really basic graphic design. Yeah, and then I cut this on the vinyl cutter here, which I really like the vinyl cutter. I got a free vinyl cutter from, like, this person. I guess they were a friend at the time. I don't know if they're a friend now. But I got a vinyl cutter from them, and yeah, it's pretty good. I guess it feels weird when I say it like that. Anyway. Let's see what the problem is and if there's anything salvageable in this light. Oh, no need to apologize. What are we sorry about? I mean, I don't know, it's like, this person I'm thinking of is she's a very kind person in some ways, and like the only thing I have against her is that she like co-founded a cult. That's like the only thing I have against her. But that specific thing is kind of big to me, so I'm like not really into that. And it's like she's distanced herself from it, but she doesn't actually want to kill it. So despite her being an alright person, and I have one of her art pieces here and this vinyl cutter she gave me, and we've tried to be friends in the past and it didn't really work out. But she's nice. I just wish that she would try to kill the cult that she started. But yeah, I got a vinyl cutter out of the deal, and I'm no longer like affiliated with any cult folks, so that would be great, you know. I mean, it'd be better if I could keep anybody else from falling into that same trap, but haven't quite figured out a way to do that yet. Oh, we are not servo AF here. Oh, there we go. So I do need to actually show you what's in this first, so gotta give you some glamour shots of this badly designed light bulb. It's not all bad though, so it looks like it's got a nice big chip-on-board assembly in there. The color quality is nice. Like, I've had this bulb in my kitchen for 2 or 3 years now. I mean, I got it shortly after moving in here, so yeah, a few years. And it's got good color, it doesn't seem to flicker, it turns on instantly, it, you know, kind of fades off when you turn it off. It's nice, it seems to have good capacitors in it, at least from the fade. But yeah, no visible heat sinks. And it was in a recessed ceiling fixture, so it doesn't fit tightly, but there's maybe about that much clearance between the fixture and then it's just like a can. So it doesn't get that much airflow, it doesn't have that much to radiate off of, so the light's good, but it seems like it might have been designed to not last that long. I don't know. Oh, interesting. DK is asking if I have to have external cooling for the DSLR. So far, I have not had much trouble with this overheating. If I'm taking still photographs really quickly, and it's a really hot day, then sometimes I've had that problem, but I haven't really usually had that trouble with video, which is nice. Sometimes the SD card is really hot when I take it out of the camera, but it hasn't complained. Certainly might have been responsible for some data loss once or twice. So, there's the front, there's the back. It's got a little foil sticker thing. Hyperikon. Hyperikon. And it's all like authentic and stuff. I almost put out a poll asking people how strongly they feel about keeping this camera versus trying to upgrade to something that has clean HDMI to have better stream video. Hyper PAR38-30 is, I think, the model number. 1220 lumens. It is a bright little sucker. Caution, use where not for use indirectly totally exposed to risk of shock. Do not water luminaries. Yes. And then we've got this thing soldered and crimped on the bottom. That doesn't look like we're taking it apart without damage, does it? So that's probably soldered. I don't see the solder on that cap. It might just be on the inner surface. Maybe that might just be damage. Definitely crimped and soldered right there. Where are the seams? I don't see any seams here, so this was probably just like one kind of stamped bucket-shaped piece like this. So I think this is the only seam, and this feels very glued. This feels very, very glued right now. I think there's snaps also, but I think it's glued. I think we're gonna have to shim this. Do I even have the right tool? No one has the right. There is no right tool for this job, right? Maybe there is. I mean, those little sheet metal shims are as close as I know, but it just feels like this is one of those jobs that like you are not designed to be getting. These are not designed to be opened. There is no elegant solution. I've got this thing that I made. Yeah, DK suggests that friction welded. That would be my guess too. There's just some there's some stuff that actually looks a little bit like glue. I'll try to show you. Yeah, a lot of times this stuff is ultrasonically welded on. I think that is glue. That liquid on the inside. I mean, that might be the weld interface, but it looks more like glue to me. Let me know what you think. The lenses are cute. But it seems to only be in a couple spots, like right there is more. Yeah, it does seem like spinning would be a nice way to attach something like this, right? So I can wedge this under the frontmost part. I can hear the glue creak. This tool is not strong enough. This is almost certainly going to damage the front surface of this, But I'm pretty pessimistic that any sort of repair is possible. I think at this point I'm just going to be tearing it down and salvaging the LED module out of this. So I don't really care about damaging the enclosure, so I'm just going to hit it with a screwdriver. Oh, the screwdriver is actually thin enough to get in there, unfortunately. It is not. I need to find that little sheet metal tool. I mean, I've got a razor blade. I don't know if that's strong enough either. Oh, more spudgers. I found a secret spudger stash. That one's the one that'll slice open my hand. This is the one that'll bend and break and not do any good. Let's try this one first so that I have a hand to try the other one with. Oh, maybe this one will be alright. I don't know. It does sort of feel like that's wedging the glue open. Maybe I can use this to get the screwdriver in. Oh, it's so dry here. Anytime I get my hands on video, I'm like, oh gosh, my skin is so dry because it's so cold, or so, well, it's been cold, so I've been running the heater, but now it's all warm, so it feels especially weird. Alright, that's working. That's not even as destructive as I expected it to be. Yeah, Servo AF is great. It's the best feature of this camera. I mean, the sensor's alright. The lens is my favorite feature, really, but that's not part of the camera. Oh no, Mike's Ready Repair says that they tore a similar light apart about a week ago, found a bad solder joint in the switching power supply circuit, reflowed it, and that fixed it, but then unfortunately the lens broke. Oh man. Wow, this is interesting. That's actually kind of a cool design. This whole thing was just a single molded piece of plastic to... Oh, so what's going on here? It looks like they're using these interior surfaces to act as... There's like one surface here that acts as a reflector, then there's another surface here that acts as a lens to spread out the light or collimate it or something. It's interesting, there are several optical surfaces here combined into a single plastic piece. And then all these little tiny lenses to diffuse the light more around the edges. But yeah, it's got like a reflector piece and then a lens just made out of those surfaces. That's hollow. There's a lens surface just right there. Yeah, the heat sink doesn't look too effective. We'll get to that in a sec. And this glue is kind of silicone-y stuff. It doesn't seem to be like epoxy. It seems to be like like just a squirt of silicone adhesive actually. Like I could maybe put this back together with a similar squirt of silicone adhesive, if I can fix it. Oh, there's a stamping here. LD PAR38 FTJ40. Lots of nice little facets here. Those facets are in the front surface. That is nice. This is just a delightful object, actually. Yeah, screw fixing it. Let's just look at this all day. All right. Yeah, this seems like it's mostly reflector, but there's also a good bit of sealant here. There's heatsink compound there. The LED chip here is really little and cute, actually. This is supposed to be a 15-watt light. We'll go to the microscope in just a sec. So you can already see the chips just looking at the outline of the phosphoryl. So that yellow stuff is going to be probably another somewhat flexible adhesive mixed with the phosphor that gives it the yellow part of the white light. Yeah, I mean, imagine something, like we're talking in chat about whether this is a reflector or a heatsink. Yeah, I mean, I'm sure it helps that it's shiny. Some light is going to end up back there, probably not that much. It does seem like mostly what's going on is this is just thermal dispersion. Like I think the heat just gets sucked away from the actual LED chip into this chunk, which I don't think this is solid. I think this is just like a cup shape stamping and then gets funneled out to here. And then there's some more sealant around here. I don't think that's thermally relevant though. I think that's just to keep it from coming apart or getting moisture in there. It does look delicious and lemony, doesn't it? That's really good. We should taste it. I'm not gonna lick it, sorry. We can get a close view at the lemon tart though. Flux residue on the solder joints. And some burrs on those edges. Probably not a problem, but if this was in a high vibration environment, that might eventually like eat through the insulation a little bit. There are probably other reasons it wouldn't work in a high vibration environment. So that fill just comes right up to the edge of that little cavity that the LED dice are put in. I'm not having a lot of luck on seeing through that. The phosphor fill is pretty opaque. But if we end up taking the LED chip off, we could try powering it up and then we'll see the LEDs glow and then maybe that'll help. Just like running a tiny bit of current through the LEDs would make them more visible under the microscope. Yeah, it's a very square sunny side up egg. That's pretty good. I need a different screwdriver. This one will work. Nope. Yeah, so Mike's Radio Repair says PAR38 is the bulb style, which is true. It just also seemed like that was the model number. I mean, specifically, it said Hyper PAR38-30, which seems to be maybe the model number. There's another thing that might be a model number, which is 3811704002 DIM, but that seems more like a date code and serial number. Oh yeah, this one is dimmable also, which I have not used in these current fixtures, but I use elsewhere, and I think it worked out all right. I forget if I really tried these particular bulbs in dimmable situations, though. I think these bulbs might have been kind of new acquisitions. Some of the LED bulbs in here I took with me from my previous place, but then this place has a lot more lights in it than where I used to live. So I think I got these bulbs when I moved in here, which wasn't that long ago. Just a few years at this point. All right. Oh, well, that didn't help, did it? You had one job. Well, not one job. I mean, it helped the moisture stay out. And if they were going for tamper resistance, it's helping with that. But if they were going for thermal resiliency, well, that explains why it's kind of heavy still on this side. Ugh. It is a little bit squishy. Do I want to desolder this or cut it? I'm definitely not putting it back together. And I think these LEDs are more useful with the longer wire, so I'm just going to cut this close to the base. What a disappointment. How much more can we find out about this? Well, we can at least try out this LED chip. I wonder if my power supply will even be able to put out enough voltage. I might have to put 2 of the channels in series. It's got silicone stuck to the wiring, which is also silicone. In this case, they're probably using silicone wiring for the heat resistance, which is nice. You had one job. So yellow is negative, white is positive. Oh, it's solid core. It's just a little floppy at the end. And the silicone, okay. Let's see if we can get it to light off 30 volts. Not all at once, obviously, but... Oh man, for the longest time I was using one channel on my 3-channel bench supply for the robot, and it's got a separate power supply now, which is kind of nice. That would be an interesting little tool, something that would help you more easily investigate like flickery light sources. So yeah, Ryan's got a problem with an LED lamp that is dimmable, but when you dim it, it flickers a lot, which I've definitely seen some that do that. It sucks. And it'd be interesting to have a device, kind of like a little like pocket spectroscope or something, but instead of showing you the spectrum of light, it shows you the time domain, like a little oscilloscope, but like an oscilloscope and a telescope in a little pocket-sized package. That's not too much to ask, right? All right, I'm going to current limit this really low right now. Not 0. I know 0 isn't real. Okay. Just like 10 milliamps. I just want these barely on. And then for voltage, I'm just going to ramp it up and see if I see anything. Start it around 0. Alright. So negative wire is yellow. This is when it would be great to have the power supply on the screen also. Should I have a separate camera for the power supply or use the Ethernet interface? I don't actually have the software option for that. So the scope supports Ethernet, but I don't, like, I would have to purchase a software unlock code to make that work, or download it, but yes, purchase it. Yeah, so Mike's radio repair is getting a little ahead and saying that if it's the soft silicone, it's sometimes easy to kind of crumble off. Yeah, it seems like it might be. We'll take a look at that in a sec. I just wanted to try powering this up first. I'm going to try to get in there, but it does seem pretty solid. I can take chunks out of it with my fingernail, actually. Yeah, that might be alright. It's not easy to do that, but it's possible. Alright, power... 0 volts, 10 volts, 20 volts, 30 volts. Now I'm going to need to put 2 power supply channels in series to go higher than that. It might not even be enough, actually. I mean, depending on how many chips they've got in series. But let's try it. I'm going to set this to similar current limit, or exact same current limit. Let's turn some of these off too. Okay, so I've got the, so this power supply has 2 30-volt channels and a 5-volt channel. I've got the 2 30-volt channels in series now. Both of them current limited to 10 milliamps and connected to the LED. One of them is set to 30 volts, and I'm going to start to ramp up the other one. So we should have 31 volts right now. Might be nice to put a meter on this, but I'm feeling lazy. 32 volts. 40 volts. Oh, I'm starting to see some lighting. This is at 42 volts. 43 volts. 44 volts. That is 45 volts, and I'm not even registering any current yet, and it's painful to look at. 46 volts. 47 volts. Okay, that's just too much. 10 milliamps, 10 milliamps is going to be too much to deal with right now. So this is not really properly current limiting. I'm just like writing right at the threshold where these things start to light, and so you're seeing the voltage differences exaggerated here. But yeah, that's a really dense little grid of LEDs. Let's get that under the microscope. That is 43 volts across this array of LEDs right now. Oh, these definitely have a current limited driver, so I think folks are wondering how this works in chat. It's definitely going to have a switching power supply with current limited output, and so they're going to have both a current and a voltage set point on this supply. Maybe not a voltage set point, because then it would just be unsafe to run open loop. But at the very least, it's going to be set so that it's regulating the supply output based on the current that it senses. So I'm going to see if we can get away with handheld microscope. The wires on this aren't quite... I can get my microscope stand to move over a little. Oh, that's kind of pretty. The microscope just can't quite deal with that much exposure. This is a great little chip. Okay. Let's not overwhelm the poor microscope sensor. Oh, am I finally hitting the current limit? Yeah, that's, geez, what is that? 46 volts. It's hitting the 10 milliamp current limit. And it's definitely not something I want to look at. It's very bright. All right, let's turn that off for a bit. Is it warm? Not noticeably at all. Great. Let's see what it would take to get into the stuff. So that's great. How much can I use this with the lens and with my own power supply? This looks like it needs a spacer. There's an orientation here, actually. There are little notches cut out for the wires that solder onto the LEDs, and those, I think, have to be rotated to line up right. Or maybe that's not relevant. I don't know. Maybe this doesn't sit directly on that. I'm gonna try to get this lined up. I think there's an air gap between the chip and this lens. Could be wrong about that. It's kind of like that, although I might need to keep some of the upper housing here, actually, if I want to mount it easily. So yeah, kind of hard to tell how that's supposed to mount. I think that this does give it a little bit of a space between the chip and the lens, so I might need to replicate that. Or just use this without the power supply. So I could cut it right here. save the mount up here. I don't even really need this part. I just need to save enough of it to make 3D printable, like to make measurements off of it so that I can 3D print my own things that use this bulb if I want to. It's a very simple shape. There are a couple of alignment features, but mostly it's just some slopes here. Let's see how much I can just cut on this. It does seem like it's not actually that hard to take, to separate this from the plastic. Oh, that's mildly satisfying. Not that. Some of that, yeah, ish. Yeah, it looks like this whole unit might just want to like wobble its way out. Let's also definitely take off the end cap. I'm under no assumptions that this is salvageable as a mains powered light bulb at this point, so I just want to break this off in some way. Yeah, maybe leave some breathing holes in the spacer, right? Maybe improve the airflow a little bit. How badly does this want to come off? So it's soldered on one point and then crimped all around. I probably just want to shim something in there. That is tight. Vise. Let's vise. Oh yeah, no, totally. I know I was barely just turning it on. Mike's Radio Repair was pointing out that that was only 0.46 watts, and this thing is rated for 15 watts. Like, yeah, no, totally. I wouldn't expect it to be warm at all. And I was just barely turning it on because it was really bright to look at directly. If we were mounting it more properly, then I would turn it on more, but I don't know. I was less interested in that and more interested in seeing the chips. Squish them threads. Yeah, right, do not stare into light bulb with the remaining eye. I've probably got some retinal damage already from stuff like that. It's possible there's power supply stuff in the very end. I don't know how likely that is. It feels like the whole thing might be full of potting material, actually. I might just have to go in with cutting tools. Oh, that sounded good. I really don't care how much I'm damaging this power supply at this point. It sounds like I was breaking something internal that was connecting this to the exterior, but... Oh yeah, so there's a little plastic shaft that goes into the metal. And I think this is breaking / separating that. Oh yeah, am I just like hulking this whole thing apart? Look at that, that's great. Smash. Hulk smash, gender binaries, and light bulbs. Yeah, that'll just like come right apart. I might want to salvage this part now and then just like peel the rest of this apart. Oh, there's some various power tools I could use to get in there. There's the hot knife. The hot knife is probably the most entertaining. It's also kind of noxious. For plastic this thin, I might just hacksaw it. Let's see how bad the hacksaw is. Car alarm. This coping saw, maybe this is overkill, but... Yeah, what am I? Clamping this is not great, is it? Maybe I want to be cutting at an angle like this. This is remarkably civilized. No, this isn't a hacksaw. I went to go grab a hacksaw and I noticed this one first. This is a little nicer because the little hacksaw I have is only supported at one end, so I'm always bending the blade. This might be enough. Enlightening, yeah, thanks. I'll file that one away under awesome dad jokes. Oh yeah. Perfect. Now I have a piece that I can use if I want for something useful. I can even save the screws. Oh yeah, let's try powering this up properly now that I can put the reflector on. So again, oh, I should really maybe label these more properly with a plus and minus even. I can print on heat shrink. I can print on heat shrink. So what did we say, like 42 volts or so? Let's make a label that just has like about the right voltage and then plus or minus, just so that when I find this in my junk drawer later, I know what to expect. So it's like answer labels. Yeah, it's a coping saw. And for sure 15 watts is what I want to write on this. I think so. 14 watts, sure. Like a tilde symbol for like about 42 volts. I'll write DC. Oh, do I want all this on the heat shrink? That's a longer heat shrink label than I wanted. It started out being just, I want plus and minus. I could put all this on the side. I'm just going to make one heat shrink label and put it on the plus wire, and then label this as whatever, like 14 watts, 42 volts, DC plus. Shorten it a little bit. Sure. YOLO. Oh yeah, oh that's, oh look at that, beauty. Oh yeah, okay. It's kind of long. I don't like how the margins have to be so long. It's like I'm using this much precious label tape. But I'm sure, I mean, you can just like make longer labels and then cut them. I think it just has a limit to how much it can like print towards, or you know, how close it can get toward the cut as you're printing. So plus is the white wire. I'm actually going to trim this a little more. I don't want such margins because it'll be hard to read this label. I'm being really lazy. I'm not getting that on camera, sorry. Watts, 42 volt DC or so plus. Great. And then that goes in here with some screws from up here. I don't know off the top of my head what I would use to, like, I don't know if I already have any more drivers for high voltage LEDs. I've got one kind of high voltage LED system upstairs. It's just like a 50 watt photon blaster for the shop. I've got some really kind of low quality LED chips on there, but I think the power supplies are all right. But those are set to kind of a higher current rating than I think this one wants, and maybe a lower voltage. I think those are more like 36 volts. This breed of 40 plus volt LED chip is kind of new to me. So how does this work? This is keyed in some way, which I assume is also to line this up with the solder joint on the LED chip. Yeah. Oh, is there actually only one way this can go in? I would expect it to be 180 degrees symmetric. Oh, how is the lens so ambiguous? I can't tell whether I just need to press on it or whether I need to reorient it first. There, looks like it's three-way symmetry. I don't know why that would be the case though. Oh, is that it? Oh, did they generously include snaps that still work after you rip the glue off? Oh, that's great, actually. Well, at least this part seems to be reusable. Let's apply some power. Okay, what is the actual current rating that I should be using for this? I mean, I think maybe you'll just have to keep an eye on the watt meter, because the voltage is going to change too. Not quite sure. I mean, the way that their power supply works is with a current limit. It's just right now I don't know what the current limit is. I could estimate it, but I mostly just have a wattage rating. God, I have a trash bucket for all this plastic scrap. This reminds me of playing with old car headlights as a kid. It just kind of still blows my mind that these are LEDs, right? Oh yeah, that's a great suggestion too. Transparent heat shrink over a regular label. Yeah, I should try that too. The like print-on heat shrink label is just really cute, and I'm excited about it. But it's like maybe not the most practical stuff. Mike's radio repair suggests a big pair of channel locks for demolition like that. I guess I could see that working, yeah. So I'm going to be expecting at most like 7 watts from each of these 2 power supplies. Alright, let's turn on... let's turn the current limit up on this power supply at least. I can probably turn the limit up somewhat high on one power supply and use the other power supply to adjust it. Alright, so I'm setting one power supply to current limit of 1 amp and a voltage limit of 30 volts. And the other power supply I'm setting to a voltage limit of 20 volts. And a current limit of, for now I'm going to set it to like a couple of milliamps, and then we'll ramp it up. So I'm turning on one power supply, and now the second power supply. And it doesn't seem to be doing much right now. 20 milliamps. It looks like it's barely glowing at this point. Let's turn off these overhead lights. Oh, a pipe cutter, right? Alright, so that's 20 milliamps or so. $50 milliamps. Oh, I'm hitting my voltage limit now. I got up to 120 milliamps, and now my second power supply is limited at 20 volts. I'm gonna have to turn that up a little more. I've got 2.5 watts on one power supply and 3.6 on the other. So nudge my voltage limit up too. Okay, both power supplies are at 30 volts limit. One of them is actually drawing 30 volts, the other one's at 21 volts. So yeah, 52 volts going on here. And I'm just going to try to increase the current limit until we get up to the rating. So this is still 180 milliamps now. 190, 200 millis, 220, 230, getting close to the limit. We're at like 7 watts on one power supply and 5.3 on the other. This seems to be about right if I current limit it to 1/4 of an amp. So right now I've got 7.5 watts, 1/4 amp, 30 volts on one power supply, and 22 volts, 1/4 amp, 5.6 watts on the other power supply. This is 270 milliamps. Anyway, here's 250 again. This is pretty bright. How does this compare to what I'm used to? It's kind of hard to tell because the setting is really different. I don't know, just comparing it to the other very similar, like I've got the same model of light running in the kitchen right now, and it seems similar. It's pretty sunny in here, but even with the sunlight, it's pretty bright. But yeah, this is a good little module now. It is nice and warm right in front of the LED, just from the light. The actual chassis is getting a little warm, but it's not that bad yet. Just right there, it's really warm. Yeah. Alright, let's turn this off. Let's see how far we can get into that power supply, just out of curiosity's sake. See if we can actually see what's wrong with it. I doubt we will, but maybe. Yeah, for thicker cable, I would certainly consider doing something different. For where I thought this would be interesting is for labeling, like, in this case, a single, what is this, like 22 gauge wire. You could certainly do that with an individual label. You'd just be cutting a very tiny thing. I'll have to try that, though. Right. Plastic is thicker than I would have expected around here. Yeah, maybe I should just take some big shears out at this. I just don't know if I can actually get the blade for that tool in this crack as it is, so I need to make that bigger first. Oh, that's the transformer. I think. No, maybe it's a resistor. There's definitely a component though inside the plug. So yeah, the power supply was like stuck way down in there and then potted. Kind of. I don't know how much of it's actually in there. Just kind of go at that. Create some conductive debris. Satisfying to kind of just peel it open. I feel like there's so much carnage on this, we need the Tuco stream to be larger. And a nice casting of this surface at least. What is that component? I think that was just a ceramic insulator that we pulverized a bit in the vise earlier. Yeah, this probably is what was making those nice cracking noises from the vise. These are bits of ceramic, and then this is the bottom of the light bulb with the wire sticking out. Yeah, that's not useful. Oh, and there's that layer of plastic we saw. So the layer of potting is actually pretty thin. I was wondering how they formed the metal. Like, it looks like the metal is formed pretty much the same shape, but not quite. So like it probably was formed to a separate die. Oh, and then there's a boundary between potted material here and the plastic. How do I have a cut on my finger? At this point, all of you are like, well, how wouldn't you have a cut on your finger? Some power resistors on this side, then probably slightly damaging. Yeah. How long until I can just push this through now? Whoa. Alright, done with you. Oh, that's cool. Nick says, fun fact, you can just buy fun light bulb shaped glass jars at Hobby Lobby that have actual socket compatible screw bases as caps. That's great. Oh, there's that nice capacitor we were noticing from the fades. Is that going to be right across the output? Oh, my desk is going to be such a mess after this stream. I was hoping to get some non-stream stuff done today, but I needed the stream distraction, I guess, right? Gotta keep that content flowing. Now I've really gotta dive into the footage backlog and get another video about Tuco Flyer out, because as I was saying earlier in the stream, the temptation is there to try to get the motion, working just right before doing another video, but I think there's plenty of content and I just need to show the process. So to that end, a video about the current stage in the process seems to be due. Yeah, keep the content coming. Yeah, I know. Working on it. I know you're probably not 100% serious, but I am also not 100% not serious. Oh, get it coming off in big chunks, just like the content. Oh. I like that when we make a little casting of the circuit board. Oh yeah, are we placing bets on whether any burnt bits are going to show up? It could certainly be a cold solder joint. Like it was acting either like something was acting, well, so it was acting like a thermostat. So either something was intentionally being a thermostat or unintentionally being a thermostat. It could have been an intentional thermostat by way of some power management chip getting too hot and having thermal cutoff, or it could be an unintentional thermostat by way of a cold solder joint. Could have also been some kind of resettable fuse thing, which is why I was curious to see if we would see the power usage change dramatically around the fault, but it just looked like it was turning off. It didn't look like the power usage changed in any other unexpected ways. So just to be clear, every component on this board is potentially being damaged by this process of unpotting it. So there's not as much we can conclusively say after taking this apart, but we can look for anything obvious and just kind of generally take a look at the design. I could be more gentle about unpotting it for sure, but I don't feel like spending that much time on a dead light bulb. Oh, that cat says that maybe it could also just be like just mechanically broken due to thermal cycling. Yeah, that's possible. Doesn't seem like a joint that was done well to begin with should fail like that, but yeah, it's possible. Got such a sunny boy on the Tuco stream today. This has such a weird... Oh, look at that. Those yellowed lines are interesting. I think that's flux residue trapped in the resin. It's possible that's thermal, but it looks like it might be flux residue. Oh man, the epoxy, or the potting, whatever, has taken an impression of the silk screen. Oh gosh, my hands are filthy. Oh, that's interesting. You know, that could have also been marker. You know, it might have been like QA testing, you know, like marking the board afterwards. Because this looks like marker strokes more than it looks like something I would expect flux to do. But yeah, it's just, I love how this picked up the silk screen too. Even the silk screen on top of the resistors. This is what I expect from 3D models, KiCad. No, it's okay. I don't want all my GPU memory going to KiCad necessarily. It's kind of like you wanted, it makes me wonder if it'd be fun to do an art project where you just like borrow expensive electronic devices and take them apart and just do castings of the circuit board, and then you just show off the castings. You know, aside from the insufficient heatsink, this is seeming like a pretty alright light bulb so far. It does look like the LED is hooked up right across this big storage capacitor. Yep. Right. That's exactly what I'm thinking. Yeah, Nick says the cargo cult appeal of an iPhone made entirely from resin castings of the internals really tickles me. Yeah, right? Like, imagine... Okay, this wouldn't let you just borrow the device, but imagine, like, disassembling it to such extremes as, like, taking all the layers out of the lithium battery and then casting each of those layers in like resin or silicone or something, and then reassembling a battery out of parts that look the same, that are just the wrong material. Like, it would be an interesting, like, that would be something, I don't know, I have mixed feelings about museums, but I would be interested to see a piece in a museum that exists to precisely replicate the aesthetics of a device like that using completely the wrong materials. But down to that, like, kind of cargo cult level of detail where all the circuit boards are modeled just perfectly. I don't know. I don't say that because I would like it necessarily, but because I think it would go really well in a museum. Museums are very themselves, and not necessarily that much else, but they're sort of a weird, distorted mirror to see society through. And that's a generalization, but I mean, I think it would be hard to be a museum without that being a necessity of just like curating, right? Curating is creating a distorted lens. You just hope that those distortions are useful and send a message that you want to send. Sometimes the distortion you try to go for is the distortion of being really far away, and like trying to be objective. Of course, we aren't ever really objective, and like sometimes that process of like trying to be objective can make it hard to examine the ways in which you actually aren't quite, and like it's not that I don't want the thing to exist, it's that I want it to be more like self-aware. This just wants to come out like that. So what is this capacitor? 3,300 microfarads, so it's not even that big. So it's 3,300 at 63 volts, LKF brand, 105 degrees C. James says, this jackhammer is made completely out of jello. Yes, basically that. Oh gosh, jello. YouTube keeps recommending me the videos from the slow-mo guys, and I tried a couple of them, and it's so amazing how much they manage to fail to accomplish their objectives. And it's just like, we're not even trying. We just rented an expensive camera, and we just like tried to do something, and we're not even gonna like talk about the process or how it failed. We're just gonna like try it, and then we're all just gonna like laugh at it having happened, and then move on and sell some ad space. Thanks 2017 or 2018 for making me feel especially old. I understand millennials well enough. I think it's just that people who are in charge of advertising to millennials these days are really strange to me. Something smells kind of weird at this point in the disassembly. I can't tell whether it's just the potting material just like getting all up in my lungs or whether there's actually something burnt in here. There's a little nick there between... It looked like this resistor kind of got scratched up against the heatsink of this transistor, but that was likely something that happened during disassembly. It's possible that it happened beforehand, but I'm going to bet that that happened during this disassembly process. If that did happen, it's possible it could like scratch the resistor and cause it to short out onto that heatsink, but the problem didn't seem like a short unless it was a short in something that would cause it to draw no power momentarily. rather than excessive power. I say they rented the expensive camera. I think it's probably at this point more like the expensive camera rented them. The expensive camera deserved somebody who knew how to set up a better shot. I gotta have like a swear jar, but for negativity. I don't know how much more of this potting I'm gonna get off. Well, I'm gonna try to at least get off enough that I can read these semiconductors. Not that that's likely to help a ton. Probably transistors, but I don't know that I care that much about the specifics. There's a little bit of maybe heat discoloration on here, actually, now that I'm noticing. So yeah, right here under the capacitor, that might have been something like glue, but I don't think this was glued down. I think it was just held down by the potting, so I'm guessing that might be thermal. And then also right here by this transistor also seems to be heat. These both seem to be transistors, but they might be ICs. And then on the bottom, there are some definitely ICs. There's a bridge rectifier. That little critter is the bridge. Yeah, so the mains comes in over here. We had this wire and... yeah, this wire and this had a wire attached to it. So I think these resistors are being used as a fuse plus inrush protection or something. So the mains goes through these resistors first and then into the bridge rectifier. And then the output of the bridge seems... oh, what is going on here? They also physically placed this capacitor right over the bridge rectifier. So this capacitor is actually the terminals to the left and right of the bridge. And the bridge, the input is over here. Those are resistors. Output is over here. Then it goes to... I would have expected it to go to a storage capacitor, but maybe it doesn't have an input storage capacitor. Maybe it just chops up every 60 hertz, or every 120 hertz cycle. I wasn't really eager to map out this entire circuit, but I was hoping we could at least look at the switching controller. I think it's got its markings missing, though. That looks sanded. I don't think this chip has markings. It looks like it was probably sanded. Or maybe never labeled, but probably sanded. Oh, there's the labeling on the bridge. So you can follow the negative rail of that all the way over here. And then out here. So obviously not an isolated power supply, which is what you'd expect in a light bulb. The negative off the bridge comes all the way over here to this main output. Oh, it's actually the positive over here. So this is actually a negative buck converter. It's like an inverting buck regulator, I guess. Oh, or did I trace that wrong? That was this bottom trace. Is the positive. Okay, that's via this resistor. Is that more inrush protection? That's 10 ohms? Or 20 ohms? Yeah, and so those two are bridged. So this capacitor that's right over the bridge rectifier is their main kind of input side high voltage capacitor. So this is going to charge up to whatever the rectified mains voltage is in your locale. So like I think here it would be like somewhat higher than 120 volts, so like 160 volts or something. And that would be between this rail, which is the minus over here, but then turns into the plus over here. And then the input voltage appears across this cap, goes through this inductor. So this is like the main buck regulating inductor. So, well, we've also got a transformer out there. Is this like for input filtering? I think this is the buck regulator inductor, but I don't know, I could be wrong. It looks like everything's coming in through that. That might just be for smoothing, to reduce ripple or something. I should really make sure everyone knows I'm not a switching power supply expert by any means. I'm just trying to make sense of this. Most of this live stream is stream of consciousness. So we're going through this inductor, then into the main switching element. No, so these are two more capacitors. This one with the heat scorch mark is going to be the switching element, right? So that's the control input. So this is the main switching controller. It's got a built-in gate driver, and then this pin over here, pin 4, this is going to be a snubber network for the gate. And then this lower pin is the gate of the MOSFET. And then these are going to be collector and emitter, depending on what the polarity is here. And so this is like the high voltage input. Yeah, so this is not the main buck converter inductor. This is for like interference suppression, I think. And then this is the main switching element, which also seems like it was getting kind of warm. And it chops up the 120 hertz signal into something much higher frequency. Then that should be going right into the inductor, right? And so we can also look at the inductor pins. We have 3 pins on the inductor. So you'd expect for a non-isolated supply, this could be an auto transformer, where it has one common and then basically an input and an output pin connected to the input and output windings. So I think this goes through here, goes, I think it would branch out to this pin as a sense pin. So I think pin 8 would be a sense pin on this chip. I don't know. Maybe it doesn't actually connect there. Maybe it just goes straight down here. But I would expect it to be going, so like that would take it over here. Is this the input side of the transformer? Got capacitors between those two sides too. C7 is interesting. We can answer some of these questions pretty quickly with a multimeter. What are these resistors? Oh, are these the shunt resistors for measuring current? Yeah, so that would make this the output side of the transformer. Then these resistors are actually passing the whole output current, if I'm reading this right. And then, why would the diode be after the shunt resistors? I guess we're measuring the current through the resistors into the capacitor during each pulse. Oh, don't touch this stuff, Took. Took, get out of here until I clean this up, honey. Oh, Tuco. I'm gonna get this stuff off my desk before Tuco gets too into it. Oh yeah, can someone drive the camera over here? I wish that was working. It's so close. Oh, Tuco. Don't want this epoxy stuff on you, honey. Oh yeah, that's an interesting explanation from Nick about the slow-mo guys. Yeah, I totally got the impression that it just started as some folks who were camera operators who also could shoot some interesting stuff and put it on YouTube, which is fun. And I'm like, it's entertaining just having people who like making interesting footage doing their thing, but like it very much isn't like doing science or anything, and it's just, it feels like with the stuff that I've seen them on do recently, since YouTube started funding them, like it's even more like, we're just gonna throw a bunch of money at this thing, and it's something. Yeah, we're gonna talk about it and be loud and yeah. And I think, I don't know. It just, maybe I'm just disappointed by the lack of execution. Go on screen now. My hands are less covered in gunk. All right, well, anything else we care about on here? We could reverse this more. But it's just a broken light bulb. I think this board is probably pretty much trash at this point. I don't think there's anything on here I would prefer to salvage. Maybe the coil, maybe the bridge, but it's all covered in this crusty stuff. There's not much to critique on here. I mean, it's hard to tell what kinds of safety features might be built into the controller chip without knowing the model number. It seemed like there was some kind of thermal cutoff, but it might have also just been a failure in the solder joints. Seems like there's some thermal stress over here, but it's kind of hard to tell. No, that is definitely the capacitor getting warm. The reason for the capacitor itself to be putting out a bunch of heat would be if the ESR was rising or if the supply was just naturally really high ripple, because then you're kind of forcing energy in and out of the capacitor really quickly, and that generates thermal losses. Yeah, right. Big Clive spends a lot of time making schematics for stuff like this, and I don't quite have the patience to do that for every random broken light bulb. If this was something I could get firmware off of it, I would be making a schematic of it maybe, but I don't know. Let me know if you want to see. I mean, if this is super interesting to you, I mean, I could spend more time making videos about this kind of stuff. But there are a lot of people on YouTube like Big Clive who I think fill that niche pretty well. This was something that just kind of came to me because this was broken in my shop, and I wanted to try to see what I could do with it. And I think where we're at is throw away this broken power supply and then reuse the LED module itself, which is pretty good. Yeah, DK also mentions that the capacitor would be getting hot if the capacitor itself were low quality and had internal problems. I don't have a proper capacitor analyzer, but we could just throw it on capacitor test and see if there's any egregious differences in between what that tells us and what the sticker does. I'm just going to use the capacitor test on my Fluke. It's not very good, but it's what we've got easy right now. This says 350 microfarads, which is close to the rated 330 even, but that doesn't tell us what the ESR is or what it behaves like at high voltages. Yeah, so I think that's junk too. The mystery IC would be interesting maybe, but I'm not going to decap it. I'm not really set up for that here. So yeah, I think that maybe wraps up today's stream. I'll keep the cat camera running as long as it's interesting though. Generally, I try to run the cat camera whenever Tuco's around these days. So if you like just hanging out with Tuco, then I've got twitch.tv/TucoFlyer, and I'll keep that running as long as he's in the area. I've also got plenty more stuff to stream. I've got actually a backlog of stuff that I want to stream just for the sake of streaming it. But I've also got stuff that I want to produce, like edited video, so I'm going to try to devote more time to that. I've also just been really messing up my sleep schedule lately with doing stuff late, so I'm also going to try to do less of that, but I'm going to keep streaming. I think it's working out pretty well to do at least some kind of really basic stream, if not a complicated one, about every day. But the timing is still a little bit random, so if you want to keep up with the streams, right now the most reliable thing to do is to follow the Scanlime Live Twitter account. But I also use the native notifications on Twitch and YouTube if you're on either of those. Let's take a quick look at that. Usually the TucoFlyer stream is silent. We might try to do some kind of audio content on there in the near future. I can turn on the mic sometimes, but usually the mic is muted. But yeah, so it's like that right now. Let's turn off this power supply. Oh, the cat's on the desk. Yeah, and so that's not a completely useless object now. It's labeled, it tells us what voltage. I can stick this in my junk bin and have a nice LED for something in the future if I bring my own power supply. Yeah, and so if you want to keep up with these streams, I've got this Scanlime Live account on Twitter. It tweets stuff like this out. You can block the individual notifications if you only want to see when streams start. For example, you can block the continued notifications. Wow, sensitive material. That's pretty sensitive. Cracking open those LED lamps. Oh man. Yeah, it tweets out screenshots. My code was not what marked it as sensitive, but I guess Twitter decided that bare shoulders are scandalous or something. yeah, I'll try to keep the interesting content coming, and sorry if I neglect live streaming like 8 hours a day, every day, all week, but I'm going to try to find the right mix between the edited content and the live streams. Let me know if you have opinions on how I should swing in that direction one way or the other, but I'm also going to try to find my own balance. But yeah, I always enjoy hearing feedback, even if I don't always have something actionable right away. And yeah, I don't know what these notifications man, Twitter. I just don't even want any of this. Go away. It's just made of distracting, like cats. But I'm okay with cats distracting me because they are generally just good for my well-being and the well-being of the people around me, which isn't something I can really say for Twitter. Oh, you're so chirpy. Gotta make sure that it's like I've got to groom him so that I get all the bits of stuff off of him before he swallows any of it, right? I don't like him on my desk for that reason, but he's being cute right now and it seems pretty clean. Oh, DK is wondering what's causing the camera to bounce vertically. That is oscillation in one of the many control loops. There's a lot of control loop tuning I should be doing. I've been neglecting that a little bit to try to prioritize editing video, but yeah, the vertical control loop especially is really sensitive, and I keep turning up the gain to try to make it faster, but if I turn it up too much, it tends to oscillate. So there's that. Oh, Tim, I just noticed Tim's comment in YouTube chat was saying that maybe that first inductor was for power factor correction. Yeah, that might be it. Yeah, and Tim was asking whether that was a FET or a BJT. That one that we were looking closely at was definitely a FET just based on how it was arranged. I'd be really surprised if it was anything but a FET. That other transistor, I didn't look closely at it. It could be a BJT, but I imagine they're probably both FETs. Yeah. Anyway, that's all for now. I'm going to continue trying to make some good content, and a special thanks to everyone who does their part to help me produce stuff and to help spread the stuff that I do produce. So yeah, special thanks to everyone who tells their friends about the show, and a special thanks to everyone who sends money my way on Patreon. That's been just helping me pay the shop rent, which is like my main expense these days, and like the less I have to find jobs separately, the more I can just keep doing this. And lately I've been able to, keep paying the rent mostly based on Patreon and savings from previous jobs, so it's been nice to be able to devote pretty much all my time to projects I get to share. And sometimes I have to change that and do other jobs to, to try that out, to try to, put more money in the bank. But the more I can do this, the more it feels like I'm putting my efforts towards something that build not only a little community that we can all, gain something from, but also something that's out there in the public and won't be just like locked up forever, the minute my employer closes shop, and won't be like aiming toward some specific goal that just makes some company or some individual or some particular cause richer, but instead just like puts knowledge out there in this form that maybe more people can use. And maybe some of it's knowledge, maybe some of it's inspiration, maybe some of it's just keeping you company, but I appreciate knowing what's working and what isn't, so I can keep tweaking it. So if you do have feedback, let me know on Twitter or on the YouTube comments or on Twitch, and I'll try to take that into account. Anyway, I'll stop rambling and get on with my day and let you get on with yours. But yeah, that's a good summary. Down with capitalism, up with curiosity. That's basically it. Not that it's possible or practical to completely escape capitalism, but I'm certainly interested in trying to aim us against capitalism as much as possible. We've all got to eat and sustain ourselves and sustain our family, but the more we can produce whatever it is we can produce, whether that's software or content or education or community, that makes it easier for us to help each other rather than like funneling everything we do through the man and then back into our neighbors. Let's try to help our neighbors more directly if we can. And for some of us, that means stuff in person. For some of us, the internet is helpful because we're antisocial hermits. But you do you, and I'll do me. But yeah. And if you want to keep hanging out with Tuco, I'll keep that stream going, but otherwise I'll try to get some work done elsewhere. I'll see you all later. Happy hacking.